there. We're getting to the end of the year. We are going to skip right by think about the situation, and we're going to get right into the notes here. So a sequence is an ordered list of numbers, or is defined as a function that has a domain on the set of positive integers. So notice that the first term has to be 1, and there's no half terms. So that's really important, that the terms are from 1 to infinity, but must be whole numbers. So that's important to understand. Sequences can be written with subscript notation or function notation. So there's different ways you're going to be able to see how it's written. So the first one, a of n, this is the nth term value. So it's basically the y value here. A of 1 is the first term. So a is that basically the term, and it's the nth term. A subscript 1 is the first term, the term that's the number 1. A of n, this is the same idea. This is really that, and this is the first term. It's just a different way of writing it. Sequence formulas can be given as a function, which is called explicit. So this can be either, I'll just give it away right now, exponential or linear. And they're just exponential or linear functions. So this example, a of n equals 2n minus 1. This is a linear function, which we call arithmetic. So the first 3 terms of the sequence, a1, a2, a3. So I'm going to list them, a1, a2, a3. And I know there's not a lot of room, so if you would like to go to the side, you can. So a1 can also be written as a of 1, which we know if we have 1 here, we're just going to plug 1 into n. So 2 times 1 minus 1, which is 2 minus 1, 1. A of 2, 2 times 2 minus 1, 3. A of 3, 2 times 3 minus 1, which equals 5. You will notice here that this is our first term, second term, third term. They go up by 2. You're adding 2 each time, which is important to know. That's the linear function, which is arithmetic. Which term has a value of 53? So this is the value. Again, as above, we said it's the value of the nth term. So 53 is actually going to go in for a of n. So a of something equals 53. So a of the nth term is 53, which equals 2 times n minus 1. Well, we'll just solve here. I know I'm going to go fast. You have a video, you can pause it. 54 equals 2n, and so therefore n equals 27 if you divide over 27. So it's the 27th term has a value of 53. Then the last one says justify why there will not be a term that has a value of 70. So we're going to go 70 equals 2n minus 1. Add the 1. 2n equals 71. Divide by 2. And n would equal 35.5. And that can't happen. You cannot have n be a non-integer. And that is why none of those can be, the 70 cannot be a value of a term. So explicit ones formulas are nice, very straightforward. Recursive is a way to think of it with a next equals now statement. So you need to think back to algebra. And you did this in algebra 2 years ago. So next now. Remember that next, the formula is written as next equals now. Some operation, usually plus or minus or multiply, of a number. And then you have starting at a value, which is another number. The a of n is the next. The now is represented by a sub n minus 1. And then the starting at value is represented by a sub 1. So in this case, we have next equals 2 times now plus 5 starting at 3. So how do we get to the first term? Well, we know the first term is 3. How do we get to the second term? We do next equals, this is the next one, 2 times now, we're at 3, so 2 times 3 plus 5, and that equals 11. How do we get to the third term? We go next equals 2 times now, that's now 11, plus 5, and so that'll give us 27. You're going to see why recursive formulas are not as nice as explicit. It says which term would have a value of 123. The only way to do recursive is to do them all out. So I know a sub 3, now I need to find a sub 4. 2 times 27 plus 5, which equals 59. A sub 5, 2 times 59 plus 5, which we are lucky enough does equal 123. So it's the fifth term. But there's no easy way to find that. You have to continue doing it out. How would you find the 40th term? Continue process from above. And you can say, not fun. You would have to do it out 40, you'd have to do it 35 more times. What a pain. So you don't want to do that. So if you remember back to algebra, you did an experiment with a rubber band. In one such experiment, for each ounce of weight added to a 3-inch rubber band, the band stretched about 1/2 inch. So for every ounce of weight added, it added another 1/2 inch. So this is our starting value. Our starting value was 3 inches. It's with a 3-inch rubber band. For every weight added on, we added on another 1/2 an ounce. So you could continue this pattern. 50 would be 28. 99 will be 52.5. The nth term, how did we get that? Well, notice here that we're adding a 1/2 an inch every time. That's a linear function. So we're going to have our starting value, which is 3. We're going to add a 1/2 an inch every time, times n. If I plug in right now 3 plus 0.5 times 50, you would get 28. So explain why the sequence above is an arithmetic sequence. And it's because we are adding 0.5 to find the next term. We'll skip D because we didn't do it. Write a next now. So next equals, how did we get to 3.5? We took the previous term now, we added 0.5, and you always need a starting at, which is our beginning term, 3. So you have to know how to write these. Next equals now plus something, starting at. How do we write it as a recursive? L sub n equals, so that's our next, now, L sub n minus 1, plus 0.5, comma, L of 1, or in this case, L of 0, but equaling 3. Next equals now plus 0.5 starting at 3. You can see. So using the recursive formula, find the length after 8 ounces. You are going to have to find L sub 0, L sub 1, L sub 2, L sub 3, and so on. Please pause the video and do that. And you should have gotten L sub 8 to be 7. So now it says write a function formula using L of n. So notice that we're going to do L of n equals our starting value, 3, plus 0.5 multiplied by n. Notice that if we plug in 0, you get 3. Plug in 1, you get 3.5. It follows the table. So use the function formula to find the length after 8 ounces. All you're going to do is find L of 8. We're going to do 3 plus 0.5 times 8, which equals 3 plus 4, which equals 7. And notice that we had 7 up here. Much easier to find it using a function formula. So describe the difference. Recursive is long. Function formula, much easier. So notice that our starting value before was a sub 0. Now we're going to look as the starting value as a sub 1. This is important. Next equals now plus the common difference starting at 1, or starting value. Here, this is our explicit. So this is our term, our value of the term. This is our first term. This is our common difference, what we're adding or subtracting. And n is the term, the number term, as in which term is it. This is the a sub n is the value of the term. Notice that we're subtracting 1 because we're starting at the first term, not the 0th term. So let's look at these next examples and then we will be done. So the first thing you have to do is, how are you moving from one term to the next? Well, 6 to -1, we are subtracting 7 each time. Arithmetic sequence. So we're going to have our f of n equals, what's our starting value? 6. Subtracting or adding, we're going to be subtracting, so -7 times n minus 1. So that's our explicit. Our recursive is going to be a sub n equals a sub n minus 1. Next equals now -7, where our starting value equals 6. So please pause it and attempt number 2. And so you should have gotten these two functions. Getting a little more difficult here. Given f of 15 equals 363 and d equals 4, you need to remember that this is the formula that we use. And so we're going to look at the 15th term. This is the 15th term equals 363. And so we're going to say that 363 equals the first term, that's what we don't know, plus the difference, 24, times 15 minus 1. The 15 is our n. So 365 equals a1 plus 24 times 14. And that's going to give us 336. We'll subtract it. And we will get 27 to be our a1. Now we got to find a1, a2, a3, a4, and a5. Well, if our first term is 27 and we're adding 24 onto it, get 51, 75, 99, 123. The explicit formula, again, our starting value is 27. We are adding 24 and always times n minus 1. To number 4, this is saying our 37th term equals -173. We're subtracting 5 every time. We want to find the first 5 terms. So again, we're going to go -173. This is our term value, equals our first term, minus 5 times n minus 1, which is 37 minus 1. You have this equation at the top of your paper. We're going to get -173 equals a1 minus 5 times 36. -173 equals a1 minus 180, and we need to get we should get a1 to equal 7. We then go a1, a2, a3, a4, a5. If we have 7 as the first term and we're subtracting 5, we just go right down subtracting 5. It's a 13. And to finish it off with the recursive formula, next, a sub n equals now a sub n minus 1. Oops, not plus, we need to subtract. Minus 5, comma, starting at, where we started at, 7. So please come into class with numbers 5 and 6 done of finding the first 4 terms and finding the 12th term. And with that, have a great day, and I'll see you in class.